All right. Good morning, everybody. 14.8 chapter review. It's going to be page 670 in your book, and you can follow along. So number one is telling us to, in each case, what's the difference between the graph of a function and a graph of a non-function. Well, a graph of a function, so this is a function graph, and this is a non-function graph. The graph of a function is going to look like something like this, or even like the red line. But a graph of a non-function would look like something like this. Um, so what happens is you go to a value of x on the graph, and for one value of x, do you have one value of y? And that's the case here. If I'm here at this x and come up to here, I have one value of y. But looking at the non-function, here's my x value. I go up, I have a value of x, a y here and a value of y here. So that's the difference. One x value is one y value. So part B, what does an as x increase in direct variation function and then an inverse variation function? So so y is equal to kx. This is direct, and y is equal to k over x, and this is indirect. Here you can see, so k is a constant. You can almost just forget he's there, or just treat him as a 1 for all practical purposes. He's just a number. Here, however, if x were to go, if x were to increase, y would increase, because they're the same. 1 equals 1, 2 equals 2. They both have to increase. But here, however, as x increases, y decreases. So if y went from, say, 2 to 4, you would go from 1/2 to 1/4, which is decreasing in value. So they're inversely related. 1C, general equation and particular equation. Well, a general equation is has letters to stand for a unspecified constant, whereas a particular equation has specific values for constants. So a general equation has letters to stand for unspecified constants. So letters are equal to some unspecified constant. Whereas a particular equations, they have specific values for the constants. So for instance, a general equation would look something like y is equal to kx. But a particular equation would be y is equal to 3.14x. So it's a particular value now for k, not just any unspecified number. And finally, 1D, it's asking us the sine of A and the cosine of A. Well, the sine of A is opposite over hypotenuse, and the cosine of A is adjacent over hypotenuse. So that was pretty painless. Number 2, tell what is meant by each of the following: leg adjacent to a given angle in a right triangle, proportionality constant, quadratic function, parabola, and vertex. Well, to look at A, we're going to be looking at the leg adjacent. So here I have a right triangle. Well, let me just flip to a new page because I want to have I want to be able to have lots of room here. Okay, so if I make this my angle, the side opposite is, so this angle, this is important to know, this angle creates these two lines. So the side opposite goes opposite across, and this is its opposite. Okay, however, the adjacent leg would be this leg here because it's next to the angle. It's not this one. That's the hypotenuse. That never changes. Okay, and even if we change the triangle itself, or not the triangle, the placement of the angle, you change the placement of your angle, you're going to be changing the placement of your leg as well. So for instance, so now this angle B, this is its angle right here. This is the legs that the angle is between. So its opposite is this side. This is its opposite. Whereas the angle B has an adjacent value right here. And again, you can't be adjacent over here because that's a hypotenuse. Now, if you don't have this right, you will always be getting your numbers backwards, as some of y'all, I'm sure, have already figured out. Okay, so 2b. Now I want to look at what is meant by a proportionality constant. A proportionality constant is the number k in the equation. So proportionality constant is k in the equations y is equal to kx, or y is equal to k over x. And just remembering direct and indirect variations there. What is a quadratic function? A quadratic function is a function of this form. So 2c, a quadratic function, has the form ax squared plus bx plus c is equal to 0, where a cannot equals, well, let me back it up, little a cannot equal 0. Okay? Otherwise, it'll just be a line. 2D is asking us, what is a parabola? And a parabola is the graph of a quadratic function. And you all love it. And it looks like this, right? All right, and then 2E, what is a vertex? And the vertex is the low point or high point in the parabola. So we have parabolas that look like that. Its vertex would be up here. Parabolas that look like this, its vertex would be right there. So high point is in your blue and low point is in the red. Number 3, plot the graph of the function for the given values of x and connect the points appropriately. So my function is y equals 0.6x squared. Oh no, not squared. Plus 2. And I'm going from -3 to +3. All right, so I create my xy plot off to the side. -3, -2, -1, 0, 1, 2, 3. All right, So then 0.6 times 3 is 1.8 plus 2, and you should have 2.8. Or no. Do I have a negative missing? Negative 3. Negative 1.8 plus 2. So it's 0.2. So negative 1.2 plus 2 is a negative, it's almost 1. It's 0.8. And a negative 1 is negative 6 plus 2, so that should be about 1.4. And 0 will be 2. And then, so we're going up 0.6 each time, so it should be 2.6, 3.2, and 1.8 plus 2, 3.8. All right, and then so you put in some, this is my x, this is my y. So I go to point -3, 1, 2, 3, and go to 0.2, so I'm about right there. -2.8, -1, 1.4, 0 is 2, 1 is 2.6, 2 is 3.2, and 3 is 3.8. Ta-da! All right, your next one is y is equal to absolute value of x minus 2, and I'm going from ranges of -1 to 5. All right, so again, you do an xy plot. So -1, this is going to be -3 in here. So -1, 0, 1, 2, 3, 4, 5. What did I say? -1 gives me -3. So absolute value of -3 is 3. So 0, so that's 2, 1, 0. And then 3 minus 2 is 1. 4 minus 2 is 2. 5 minus 2 is 3. So like most absolute value functions, if you get a quadratic, it looks like a U or an N. If you get an absolute value function, it looks like a V. So -1, 3, 0, 2, dot, 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 1, 2, 3, 1, 2, 3, 4, 5. Well, I missed one. Okay, I'm missing something. -1, 0, 2, 1, 1, 2, 0, 3, 1, 4, 2. Oh, there you go. All right, so then your graph looks like that. Pretty simple. Remember, absolute value bars creates this graph. It should be a line. It should keep going down, but it bounces off because it's absolute value. It's not negative. So it literally changes direction and keeps going. Here we get y. This is 3c. Y is equal to 6 over x. So 6 over x, for x is equal to 1, 2, 3, and 6. So xy, 1, 2, 3, 6. Well, that's 6, and that's 3, and that's 2, and that's 1. So my point is going to be 1, 1, 2, 3, 4, 5, 6 right there. 2, comma 3, 3, comma 2. Well, no, 3, comma 2. Something's wrong. Nope. And then 6 comma 1. Okay. So it looks like this. All right. So good so far. So far, so good. Here we're looking at 4A. Food problem. The number of pounds of food you need to take on a camping trip varies directly with the number of days you will be gone. Suppose that a 10-day trip requires 17 pounds of food. So 10 days and 17 pounds. First, they need to find the proportionality constant and write the particular equation expressing pounds of food in number of days. So I need pounds of food. So I'm going to let x is equal to the number of days, and then y is equal to the pounds of food. You may be thinking to flip these, make y is equal to days. Always on your x-axis, x is always time. If you have anything to do with time, minutes, hours, days, seconds, years, time is always going to be on your x-axis. All right. So then what we're doing is we are joining a muted version of 4.8. We're on page 670. I'm on number 4A for those who have lost track. So y is equal to kx is our variation because they said it was a direct variation, varies directly with the number of days. So my xy point is 10 and 17 because it was 10 days and it was 17 pounds of food. And again, because I have x, my x is number of days, and my y is your pounds of food. So then I plug these numbers into this equation. 17 is equal to k 10. So k is equal to 17 divided by 10. So this, what I wrote up here, really needs to be flip-flopped. So it should be 17 over 10. All right, and then k is equal to 1.7. So that's 4a. That's the crux of 4a. I can chisel in b right here. Should be easy. B is just says that how much food should you pack for a 28-day trip? So what is days? X. So what is my equation? Y is equal to 1.7x. So let's plug in 28. So y is equal to 1.7 times 28. And then so y is equal to 47.6 pounds of food. And I think I can chisel in C here as well. How many days can you stay if you need 50? If you bring 51 pounds of food? So again, y is equal to kx. This time y is equal to 51 pounds, and you're going to solve for x. I wrote that with I wrote the general equation and not the particular one. Right, the particular equation. Here's my working equation. So then 51 over 1.7 is equal to x. X is equal to 30 days. Make a better 0. 30 days of food. All right. So 5A, a music practice problem. Clarinet. Clarinet. Figures that the number of mistakes she will make in a piece of music varies inversely, guys, backwards now, with the number of minutes she practices that piece. After 20 minutes of practice, she finds that she makes 4 mistakes. So 20 minutes and she makes 4 mistakes. Okay, so y is equal to k over x. I need an x and a y. What am I going to use? Well, I guarantee you that the time is x. Look at there. There it is. The time is x. Just a little FYI, x is always time. So anytime you have a day, a week, an hour, a minute, a second, a millisecond, it doesn't matter. You always put time on the x-axis. So here I solve for my general equation for my particular one. I put in this stuff right here. So that gives me k is equal to 80. So then therefore my working equation, or my general equation, a specific equation actually, is y is equal to 80 over x. So looking at the B version here, they're going to ask you how much time does she need to make 1 mistake. So if Clara wishes to make 1 mistake, she needs to go 80 minutes. And then it says here, it says if she only had 5 minutes to practice, how many mistakes might she have made? Well, if she only has, sorry, I did that last one backwards. I just realized. So for B, you should have the number of mistakes is 1 is equal to 80 over x. So therefore, x has to be 80. Sorry, I was solving for the wrong version. In this case, we're going to use y. In C, I'm going to use y over equals 80 over 5 because I only have 5 minutes to study. So therefore, y is equal to 16 mistakes, whereas the B was 80 minutes. So these are your two solutions there. All right, moving on to 6. Number 6, it says find the length of the side x. So here's my right triangle. X is here, 21 is here, and I have 42 degrees in here. So what do I write at the top of my page? SOHCAHTOA. If you don't know SOHCAHTOA, give me a call and ask why. You would write SOHCAHTOA. So to find x, x is my adjacent side. So x, the angle is 42, x is my adjacent side. So I'm going to use adjacent. And also I have my hypotenuse. I have a hypotenuse here. So you can see that I'm using my adjacent because I have the A of the ka and I have the h. So if I have A and h, I need to use a cosine function. So I use cosine of 42 degrees is equal to adjacent over hypotenuse, which in this case is x over 21. So in this flip-flop version, all you need to do is flip-flop, multiply everything by 21, sorry. So you get 21. If I multiply this whole spiel here by 21, I get 21 cosine of 42 is equal to x. And that ends up being 15.61. B is going to ask you, well, let's just flip pages here so I can write nice and big. 6B, here it gives you a kind of a crazy one. So never fear, your right triangle's right there. And it's asking me to find the measure of angle A. So what do I have available? Well, let's label my stuff. So A is here. That means the angle across, this must be my opposite. And if I'm beside, this must be my adjacent. So I have opposite and I have adjacent. So if I wrote at the top of my page, like you should on every trig problem, SOHCAHTOA, which ones give me which one can I use with the O in the A, and it's the tangent. So I can write the tangent of the measured angle A is equal to my opposite, which is 24, over 13. And then so this is where it gets tricky. The angle itself is equal to the tangent inverse of 24 over 13. Now you need to learn how to use these on your calculator because at this point it is purely a calculation. But that's going to give you approximately 61.56 degrees. Come back and see me on tomorrow's Zoom if we do not know how to do this tangent inverse. It's quite important that you know how to do it. All right, so never fear, we only have a few more left. Number 7. We are at the quadratic function y is equal to 3x squared minus 14x plus 8. Evaluate y if x is negative 5. So f of negative 5. So let me just rewrite this guy. So if y is this, I'm going to just rename them and call them a function of f of x. So what is f of negative 5? Well, it just becomes my same f of x with negative 5 inserted in here. It's really quite easy. You just punch in a negative 5. It's a plug and chug at this point. So your answer there, to save y'all the torture of me calculating it, it's y equals 153. For the B version, they're asking you to solve for x if y is more than 19 and draw the graph. So if 3x squared minus 14x plus 8 is greater than 19, well then you have to bring over your 19 and get everything greater than 0. And the reason we equate it to 0 is because we can use your quadratic formula. And you get x is equal to 14 plus or minus the square root of 328 all over 6. And then therefore x is approximately 5.36, or remember you have an x squared, so you have two x's that are possible, negative 0.69. And then they want us to draw that graph. I'll draw it right here. The graph there would be going from negative 0.69 to 5.36, and because it is a greater than symbol, it's non-inclusive, so we draw circles and the arrow going where we need to go. The next thing we're going to look at is 7C. So 7C, we're going to do less than or equal to 125. So 3x squared minus 14x plus 8 less than or equal to 125. 3x squared minus 14x. Bring over the 125. So you have negative 117. Again, quadratic formula. 14 plus or minus the square root of 1600 over 6. X is equal to 9 or negative 4 1/3. And then its function would be negative 4.33, 0, and 9. And you're going to be you're going to be inclusive here, and you're going to be between these 2 points. So outside of the 2 points, your function doesn't exist. It exists inside these 2 points. And then 7D takes the same formula, and we equate it to be greater than or equal to -20. So then that again is going to lead us into the quadratic formula, and you're going to get x is equal to 14 plus or minus the square root of -140 over 6. Hallelujah, we got something we can quit on. You cannot take a negative number. That does not work. So there is no solution. But what is a graph of no solution? It's nothing. It's just a 0. But my question is, actually, back up, no, because it's a greater than, it's not a no solution, actually. It's a greater than. It is not solvable because it never touches the x-axis. It has no endpoints. It has no endpoints. So therefore, it's all real numbers. S is equal to all real numbers. This will work for all x values. All right. So looking at number 8, sketch how the parabola is showing how the graph of ax squared could be between 2 endpoints, between 2 empty set. Okay, so what's going to happen here is we have 4 ways of showing a parabola. You can have it look like, let me just draw my four ways here. So you can have a parabola that looks like this, and therefore your endpoints would be between. You can have your parabola be like this, and it only exists outside. It doesn't exist inside the function. You can also have a parabola that never touches the x-axis, but is above the x-axis. And you can also have a parabola that never touches the x-axis, but is below the x-axis. So in the case of the red, these numbers are going to be, you're going to be between. In the blue, these are beyond the points, your endpoints. For the green, this is what your empty set looks like. So this is your null set, and then I wanted to do this in orange right here, and then your orange one, that is S is equal to all real numbers. All real numbers. All right, number 9, we are looking at a baseball problem. Popped up, hits a ball with an initial velocity of 23 meters per second. The top of the grandstands is 20 meters above where the pop ball hit the ball. For what interval will the ball be at least as high as the top of the grandstands? So you have to remember this formula. 20d is equal to RT minus 5t squared. That's its working formula. In this case, R is equal to 23. So your particular equation is D is equal to 23t minus 5t squared. You reorganize this to get everything onto one side and 0 onto the other. And I have to say D is greater than 20. So then you have this right here becomes 20. So then when you pull all that together, you're going to get T from a quadratic equation, or from the quadratic formula, is -23 plus or minus square root of 129 over -10. once you punch in your numbers there, you get t is equal to 3.44 or 1.16 seconds. So you're 1.1 seconds to 3.4 seconds that the ball is up above the top of the grandstands. Okay. Let me just give me just a second, guys, and we will get back into this for a second. Sorry about that. All right. So number 10, it is going to be your rectangle problem. Your rectangle problem is number 10. And it's showing you a rectangle is 7 meters by 9 meters. So you have 7 by 9 is your problem. A new rectangle is formed. A new rectangle is formed that is x meters longer and x meters more narrow. So what we're going to do is we're going to have a new rectangle that punches out a value of x, but then decreases by a value of x here as well. So my original is in black and my new one is in red. So it goes longer and thinner. For what values of the x will the new rectangle have less than 80% of the area of the original triangle? So this is an area problem. So we're going to let x is equal to the number of meters of extension or contraction. So how much x is right here? How much did it grow? And then how much did it decrease? So this is my value of x right here. And it's the same value as this one. It's not to scale, sorry, but I'm drawing with basically my finger here. L is the new length. And then so I need to get it in a situation where my length times my width is less than 80%. This is 80%. It's 0.8. It's decimal form of 80% of my original length and width, which was 9 and 7. So when I take these two and I multiply them together, you're going to get a binomial. You're going to get the two binomials being multiplied together. And it's going to be less than 50.4. Let me rewrite that a little bit better. 50.4 meters squared. This works itself out after you multiply everything out to negative x squared minus 2x plus 12.6. That's going to be less than 0 because we pushed everything to one side so that we can use the quadratic formula, which produces this here, and then your x gives you negative 4.7 or 2.7. And on a graph, it's going to look like this. So it can't be negative. That doesn't work for us. So your answer is going to be, it's going to be over 2.69 meters or over 2.7 meters. So once you go over 2.7 meters moving this way, then it's 80% of the original volume. I wouldn't worry about reviewing many of those. I'm not going to give y'all anything that difficult. I don't like those problems. Two head problem. All right, solve the inequality. X plus 5 over x minus 2 is less than or equal to x plus 4. So the first thing we have to do is we have to say that x minus 2 is going to be greater than 0. I've lost my place. You must first multiply each member by x plus 2. Yeah, I'm not going to give y'all anything this hard either. So just take 11 and consider it not consider above your pay scale. So that's the end of the chapter, and that's the last end of the year. So I hope y'all had a good time and do well on a test. I'll see y'all soon.